Now, if you, like me, are connected or bridged to a live network, this, my friend, is a demonstration you want to watch only and not do, because we are going to actively attack a DHCP server. And because I wanted to do this in a closed environment where it's not going to affect my production network, I'm going to leverage a demo that I've already done in a course that you also may enjoy watching at some point, which is the Penetration Testing with Linux Tools course. So I'll walk you through the lab setup that I'm going to be using for this specific demonstration, which involves a Cisco router running as a DHCP server. And I'm also going to be using a tool called Yersinia, which is part of Kali Linux. It's also part of the predecessor to Kali Linux, which was called Backtrack. So whenever you see somebody using Backtrack or Kali Linux, we're talking about a distribution of Linux that has a boatload of attack and hacking tools built into it.
I'd like you to imagine that you and I are going to watch a race. And as the runners are getting ready, their shoes are all tight, they've stretched, they've gotten into the blocks, and they're waiting for what? They're waiting for that gun to sound off so they can take off down the road. Now, what would happen if we hid the gun so they couldn't start the race? You know, that situation applies to a computer network where we have a lot of DHCP clients. What does a DHCP client do when it boots up on the network? Well, it sends out a discover, is looking for a DHCP server, it wants an address. What would happen if we caused a DHCP server not to be able to respond? And that's what this nugget is all about. We're going to implement a DHCP starvation attack. So for example, let's say this is the network segment of 192.168.1.0/24. And this device here is not only acting as a router, it's also acting as a DHCP server. Regardless of who the DHCP server is, the concept is the same. When the client boots up, it sends out a discover, and it gets an offer, client says a request, and then we finally have an acknowledgement in IP version 4 anyway. That's the 4 packets involved with DHCP. Then the client has its IP address, knows its default gateway, knows its DNS server, and it's off to the races. Well, the DHCP server can only support, there's only 254 possible addresses on a /24 network. So if that pool of addresses, in this guy's probably using 1, and there may be a few other reserved addresses, if we take our backtrack system and we issue discover, we're asking and asking and asking for an IP address, and we take all of the IP addresses that this DHCP server has to offer, what's he going to do for the other clients? The answer is, once he's out of IP addresses, he won't be able to hand out IP addresses to the real clients. So a starvation attack can be implemented in about 3 or 4 seconds. We can starve out and use all of them. So we use source MAC addresses that are all unique for all these DHCP discovers. The router's handing them out like crazy. Once he's completely out, we can then do several other things. We could have this guy be a DHCP server, and then we could do our man-in-the-middle attack based on that. The goal of this video is to simply implement the actual DHCP starvation, and we're going to use an amazing tool called Yersinia inside of Backtrack. Also have here a console for a Cisco router that is also acting as a DHCP server. So let's give him, let's do some show commands on him just for a moment to verify where he's at regarding IP DHCP services. So this output here of the show IP DHCP binding says, okay, here's all my current IP addresses that I've leased out. The answer is he hasn't leased any IP addresses yet to anyone. Now in a typical environment, we would see several leases from the production router out to devices who had previously requested IP addresses from the DHCP server. Another fun command is to show IP DHCP server statistics on the Cisco iOS router, and that's going to have a whole bunch of details regarding how hard this guy's working. So effectively, he hasn't seen any requests, he hasn't sent any offers, there's very little, there's no activity going on whatsoever. There's one pool, one DHCP pool of addresses, and hopefully it's for a network that he is either directly connected to or that a DHCP relay is going to forward a request for. And if we want to see the details of this pool to take a look at the exact range involved, we do a show IP DHCP pool, and there it is. And it currently says we've got 0 leases. We knew that from up there. And the range is the 192.168.1 network. So let's have some fun with this. I'm going to go to the command line, the console on Backtrack, and I'm going to launch Yersinia, Yersinia. Now to get the help with a tool like this, like Yersinia, we can do a -H for the help, and that gives us these beautiful options right here. And there's one option here, the I, which will bring it up in interactive mode, which I used to love that. It's just basically a text-based, non-GUI based way to implement it. So instead of using the -i, what we're going to use is we're going to use -g, which is the graphical version of Yersinia. And it works very well too. So to launch it, we're going to type Yersinia, and the option is a -g, uppercase G, and that brings up the graphical window. So what I'm going to do is I'm going to say okay to this warning saying this is a beta version. Okay, fair enough. And I'm also going to maximize this. Over here on the left, it's going to indicate what it sees. So it's in a few moments, if there are CDP messages being sent by the router, that happens every 60 seconds by default. We should have some CDP packets incrementing. Looks like HSRP is running. But our goal here is dynamic host configuration protocol server exhaustion. Now, how do we implement this? Oh my goodness. To implement the attack, we're going to go to DHCP. We're going to say launch attack. And then you have this window that comes up, and it gives us the DHCP tab because that's where we're starting. You could actually launch any of the attacks from right here. And I'm going to say, I want to send DHCP discover packets, just like that. That's all we need to do. And what it'll do, it'll just go like a horse for the barn. It'll start sending discover, 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 and with different MAC addresses. And that DHCP server, without any kind of protection, is going to simply hand them all out in like 3 seconds. So let's go ahead and click on OK, and it's done. So it's still actually running and running and running. This guy's not stopping. And I'm going to go ahead and tell it to stop. I'm going to say list attacks. And there's my attack list right there. And I'm going to say, please cancel all current attacks. Okay, so now it's stopped. Let's go take a look at the router. Now, here's a funny story. I tried this on a smaller, like a 2800 series router, and that dude went belly up. He just couldn't handle it. I was trying to show commands. He was like, it just locked. And after about, I don't know, about 45 seconds, it came back and let me start, doing commands again. But if that was a production router, that shouldn't be the default behavior, just simply to lock up. So now let's go ahead and do those same commands again. I'll use the up arrow key. We'll do a show IP DHCP binding. Oh, that's cool. So it started off at 1 and 2. It handed out all these addresses. Let me go ahead and make sure they're all handed out. We'll use a space bar to go up one page at a time. And sure enough, all the way up to the last one should be 253 because I told it not to hand out 254. It pretty much doesn't have anything else to offer as far as IP addresses out for clients. So we take a look at the number of leased addresses. In our subnet, there's 256 positions, if you will, or values in 1 octet of data. And we can't use the 0, that's the actual subnet. And we can't use the all bits on, that's 255. So that leaves us 254. But we only leased out 252. Well, one of those was being used by the router. He couldn't hand that out. And one was being used by this current backtrack system. So it couldn't hand that out. So effectively, it handed out all the other available IP addresses that were not in use. And now they are. So now a current client, when it boots up and does a DHCP discover, this DHCP server is not going to have anything to offer that client. If you want to do a man-in-the-middle attack, you could bring up your own DHCP service, you could route that traffic, and then you could actually be the man-in-the-middle and the default gateway for those brand new clients who need to get off the local network and need an IP address to do it. In this video, you and I have taken a look at how easy it is to implement a DHCP starvation attack, also sometimes referred to as a DHCP exhaustion attack. So the question, I suppose, is how would we protect ourselves against something like this? And the answer is it's normally done at layer 2, on a layer 2 device, a switch specifically, that can go ahead and support that. So let's say this is our switch and we've got a bunch of ports. So we'll make this, well, I say a bunch. I'm going to put 5 ports on there. 1, 2, 3, 4, 5. And all of our devices are connected in there. The router's connected. The PCs are all connected. And let's say we have a dedicated DHCP server for the purpose of this discussion. So we'll call this guy a DHCP server. And he's connected right there. All right, and then we have clients. So I have client 1, client 2. Maybe the router isn't the DHCP server, so maybe we have this guy be a router. There's the router right there, and other devices. Maybe this is a printer. So there's our beautiful 5-device network with the DHCP server, a couple clients, a router, and a printer all connected. Now the solution to protecting against this specific attack, where maybe this is the attacker right here, sending all the discovers in, he has to spoof a source MAC address for every single one of those requests. So there's 250 plus MAC addresses that he's sending into the network as far as source MAC addresses, along with the discovers. At the switch, we could use something called port security. And port security, now on HP and Cisco and Juniper, they might have slightly different names for it. But the concept of port security is saying, you know what, Mr. Client, we're going to limit this interface on the switch maybe to 5 MAC addresses. 5 source MAC addresses. You probably only should need 1, but you know, if there's some virtual machines or something else you're working with, that's fine. But if we limit the MAC addresses to 5, once that guy has sent in 5 different source MAC addresses with his discovers, he won't be able to send any more because at layer 2, we're stopping him from spoofing any additional source MAC addresses. There's also some other features like DHCP snooping, which we can also set up as a trusted port for this DHCP server, and then rate limit right here. That would also help. But the primary stop for this specific attack is to go ahead and use port security on all the client ports, simply to not allow them to send in all those different MAC addresses as they request various services from our DHCP device. I have had a lot of fun. I'm so glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.